This chain remains the same. This is a carbon, OH. Now it becomes a double bond, carbon, double bond, N. Now the double bond N becomes single bond N. Single bond N, H, again NH, phenyl. There is one more hydrogen, right? Now I am doing rearrangement again. I am making this bond to shift here, this bond to shift here, and I am migrating this hydrogen from here to there. So I am doing tautomerism one more time. So product will be this carbon chain length remains same. This converts into C double bond O. This is C H2 N H again N H phenyl. Now with the second mole of phenyl hydrogen, this is now allowed to react with second mole of phenyl hydrogen PH NH NH2. Again H2 elimination, from here hydrogen, from here oxygen, H2O is gone. So it will be H C H NH NH phenyl C double bond O N NH phenyl. Remaining carbon chain length as it is. Right? Now I am doing tautomerism again by migrating this H back. So it will be C H NH NH phenyl double bond C NH NH phenyl. Remaining carbon chain length as it is. I am not changing remaining carbon chain length. Right? Now I am allowing to react with the third mole of phenyl hydrogen. With the third mole of phenyl hydrogen. Right? So observe what I am doing. First I will do. First I am eliminating aniline. Right? So observe how I am eliminating aniline. Let me write this first. Observe this. I am migrating this bond from here to here, this bond from here to here, and this bond from here to here. And I am migrating this H from here to here. Right? So PH NH2 got eliminated. Then product will be C double bond N NH phenyl, remaining system as it is. Here it converts into single bond C double bond NH. The remaining carbon chain length as it is. Now I am taking the third mole of phenyl hydrogen. This is the third mole of phenyl hydrogen. So from here NH2 group, and from here hydrogen. I am removing NH3. If NH3 is lost, remaining thing I am writing. This carbon chain length remains as it is. This is a carbon, double bond N. This is a double bond N. From here and here NH3 is eliminated. So what is left? NH phenyl. So I am writing that NH phenyl. Above chain length C H double bond N single bond N, again phenyl, this is having hydrogen. Now between this lone pair and hydrogen, I am forming hydrogen. This is acetone. Right? So glucose or fructose reacts with how many moles of phenyl hydrazine to form acetone means 3 moles. Right? So this acetone is having intramolecular hydrogen bonding. And hence it is stable. Response, sir. Any questions in it?
No questions.
Next, one more note, right? Bayer, by observing all these reactions, give a prediction, right? We call it as hypothesis by Bayer, right? So therefore, based upon all these reactions, glucose structure can be given as presence of one aldehyde group on the top, right? Remaining carbons are having HOH groups 1, 2, 3, 4, 5, and one more CH2OH group at the end. Now, I am writing remaining structures as it is. Right. So this structure was predicted by Bayer. Having how many chiral carbons? This is 1, 2, 3, 4. 4 chiral centers. This is first carbon, second, third, fourth, fifth, sixth. So this is last chiral carbon, right? So total it have 4 chiral carbons. As we have OH group on last chiral carbon towards right side, we call this as a D form. Because of D form only, we call it as dextrose. Now, based upon this, one cyclic form was also predicted. We call that cyclic structure as Haworth projection. So what we do in Haworth projection means the lone pair electrons present on 5th carbon from oxygen. This oxygen can donate this lone pair of electrons to this carbonyl group and make this pi bond to shift towards oxygen. As this is sp2 carbon, this oxygen can donate lone pair of electrons either above the plane or may donate below the plane. So both are possible. So anyhow, you will get one cyclic form. We will discuss about that cyclic form separately. Right? This is how the structure of glucose was predicted. Right? Just I am repeating again. With hydrogenated red phosphorus, you got an hexane. Reacts with NH2OH to form oxime. With a HCl to form cyanohydrin. With mild oxidizing agent, bromine water, you got gluconic acid. With concentrated sulfuric acid, nitric acid, you got saccharic acid. This confirms presence of aldehyde group and primary alcohol group. With acidic anhydride, you got pentaacetyl group, pentaacetyl product. So it predicts the existence of 5 OH groups. Then it can form glucoric acid, gluconic acid, sorbitol, glycinol. All these confirms presence of continuous carbon chain with OH groups. With 3 moles of phenyl hydrogen, it forms glucosidone. Same product is obtained from fructose also. Based upon all these reactions, the structure of glucose was predicted. Any questions are up to here?
No, sir.
Right.
No, sir.
Now I'm giving a note. So one note here. If it is heated with NaOH, first it turns to yellow and brown and then finally converts into a resin, right? So let me write that as point 1. Glucose in presence of dilute NaOH, glucose will convert into, rearranges to fructose and mannose. If it is dilute NaOH, it can convert into fructose and mannose. We call that as Wittgenstein rearrangement, which we have seen in earlier. Now we are talking about reaction with concentrated NaOH. So when glucose heated with NaOH, it first turns yellow, then slowly turns to brown, and finally racemizes, converts into a resin. So resinifies. Now, second reaction. This is about cyclic structure of glucose. So prediction of cyclic structure of glucose. How they predicted this cyclic structure of glucose. One, glucose on reaction with acetic anhydride, you will get pentaacetate of glucose. When this pentaacetate of glucose allowed to react with hydroxylamine, there is no reaction. But actually, glucose should react with hydroxylamine. Glucose reacts with hydroxylamine to form oxime. But when you take this one, here only OH group will convert into acetyl group. Means aldehyde group should not be disturbed. So when this pentaacetyl group is allowed to react with, pentaacetyl glucose is allowed to react with hydroxylamine, there is no reaction. Means that aldehyde group is not free. So first prediction, when pentaacetate of glucose allowed to react with hydroxylamine, no reaction. Next, fails to give test with Brady's reagent and skips the test. Glucose fails to give test with skips base or skips reagent. Para-rosaline, just I will show what is that skips base test. Skips test. Here. Para-rosanine hydrochloride, right, which is magenta in color. This in presence of sulfur dioxide becomes colorless. We call this as Gibbs reagent. This Gibbs reagent, when allowed to react with either aldehyde, generally ketones doesn't show, with aldehydes, that color was restored. This confirms presence of aldehydes. We call this as Gibbs test. If glucose have aldehyde group, then magenta color of Gibbs reagent should be restored. But glucose fails to restore the color of Gibbs reagent. So with Gibbs reagent, no reaction. Means aldehyde group is not free. Any questions, sir, in this?
No, sir.
Sir.
Next.
No, sir.
Another reaction. With
Sir, can you
Brady's
explain this
reagent.
again, sir?
Yes, sir?
Sir, can you explain this again?
Right, nothing there. See this. Para-rosanine hydrochloride. This is para-rosanine hydrochloride compound. We call it as fuchsin, right? Which is magenta in color. We will pass sulfur dioxide gas. Sulfur dioxide is a reducing agent. So by passing sulfur dioxide, we got corresponding sulfonate. We call this as Gibbs reagent, which is colorless, right? So this SO2 group attacked on this NiH2 group to form this Gibbs reagent. Aldehydes will restore the color of Gibbs reagent. Means we will restore magenta color. That confirms it is reacting with aldehyde. If aldehyde group is not present, Gibbs reagent color will not be restored. So in short, Gibbs reagent with aldehydes gives magenta color or pink color that confirms presence of aldehyde. So to identify aldehyde functional group, just that aldehyde possessing compounds allowed to react with Gibbs reagent. If you get magenta color or pink color, confirms it is aldehyde. Otherwise, it is not aldehyde. Clear?
Yes, sir. Thank you, sir.
No. With Brady's reagent. Brady's reagent is 2,4-dinitrophenylhydrazine. We call it as Brady's reagent. With Brady's reagent also, no reaction. With the Brady's reagent also, no reaction. We also got as 2,4-DNP test. Dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. We call it as Brady's reagent. With a Brady's reagent also, no test. Right? In Brady's reagent, we have this NiH2 group. And glucose, if it have aldehyde group, from these two, H2O will be eliminated. Means reaction should happen. But glucose fails to give this test, means that aldehyde group is not free. Pentastate of glucose doesn't react with hydroxylamine, fails to give Gibbs reagent test, fails to give test with Brady's reagent, fails to give test with sodium bisulfate and ammonia. Glucose fails to react with ammonia, fails to show the reaction with sodium bisulfate. Right? In these two cases also, no reaction. All these confirms aldehyde group is not free. Above reactions confirms presence of aldehyde group. But all these reactions failed means that aldehyde group is not free. Why that aldehyde group is not free means If this OH group donate lone pair of electrons, it will convert this aldehyde group to alcohol group, forming a cyclic structure. So all these reactions predict the existence of cyclic structure, right? Same way, one more reaction. Glucose with the Grignard reagent, RMGX. If you have either aldehyde or keto group, RMGX should go and attack, right? To form higher carbon chain. But glucose with Grignard reagent shows only acid-base reaction, means only presence of OH groups is confirmed, but not aldehyde group. So shows only acid-base reaction with OH groups, but no reaction with aldehyde group. But no reaction with aldehyde groups. So all these reactions conforms. Therefore, aldehyde group is not present or not free in glucose. Therefore, to explain this, a scientist by name Haworth gave one more structure. We call it as Haworth projections. Therefore, Haworth projection with hemiacetal group is predicted for glucose. Right? Haworth projection means nothing but that cyclic structure. Right? Now I am showing that cyclic structure, sir. So I am taking that chain form of glucose. This is the chain form of glucose. This is the chain form of glucose. Right? So I am taking that chain form of glucose. Right? When that oxygen donated lone pair of electrons, when this oxygen donated lone pair of electrons, now what happened? This is that carbon. So first carbon, second, third, fourth, 5. This is that sixth carbon. Are you able to understand, sir? When this oxygen donated lone pair to the first carbon, I am writing that first carbon here. There is bond between carbon, oxygen, and this carbon. And here it converts into OH group. And the remaining carbons have HOH, HOH, HOH. Right? This is that cyclic form obtained. So when this donated, you may get this OH group either above or you may get that OH group below also. Both are equally possible. Right? So I'm drawing those structures. So from cyclic form of glucose, when oxygen donated lone pair, you will get a chain form. From chain form, you will get cyclic form. On cyclic form, you have other substituents. Here I am writing that CH2OH group. Right? Now, here on first carbon, this is the first carbon, first, second, third, fourth, 5, 6, 6 carbon chain. Now on first carbon, this OH group may be either below the plane or that OH group may be above the plane also. That OH group may be above the plane also, like this. So both are equally possible, right? Remaining On second carbon, whichever groups are on right side. On second carbon, OH is right side. So whichever is on right side, write them below. The groups which are on right side, I am writing below OH. Then you will get H, then OH. Remaining I am filling. Here I am writing H, here I am writing OH, here I am writing H, here also I am writing H. H. Here also I am writing the same. H, OH, here also H, H, OH, OH, H, H. Now, if this CH2OH group and if this OH group both are on opposite side, then we call it as alpha form. So we call it as alpha D glucopyranose. Alpha D glucopyranose. This is called beta D glucopyranose. Alpha D glucopyranose, beta D glucopyranose. Both are mutually interconvertible. Now, they have configuration difference only on first carbon. That's why we call them as anomers. They have difference in configuration only on the first carbon. So approximately this is about 0.02%, around 36%, and this is around 64%. Means glucose on withstanding, slowly it will convert to its beta form. Right? Any questions, sir? Respond. Do you have any questions in it?
No, sir.
No. How to differentiate between these two? Both the forms have different properties. Both doesn't have same properties. Alpha form is obtained by crystallization from concentrated solution of glucose at 303 Kelvin. And its melting point approximately 146 degrees centigrade. And its specific rotation, optical rotation at T degrees centigrade, it is approximately equal to 111 degrees. Beta form, it is obtained by crystallization of hot and saturated aqueous solution of glucose at 371 Kelvin. Melting point approximately 150 degrees centigrade. Specific rotation approximately 19.2 degrees. No, as both are mutually interconvertible, right? So the net rotation will be, this is 111 degree into 36%. And this is 19.2 into 64%. Then this value is approximately equal to 52.5 degree. Right? So that's why when glucose is dissolved in water, that solutions have an optical rotation of 54.5 degree. Right? So I'm writing that point also. When glucose dissolved in water and allowed to withstand dissolved in water and allowed to withstand specific rotation gets adjusted or changes. You take any either beta form or alpha form, any one form if you take. If you dissolve that in water and if you leave it undisturbed, slowly that also converts into 52.5. Reason? Alpha form can convert into beta, beta also can convert into alpha, both are interconvertible and they get adjusted with a percentage of 64 for beta and 36 for alpha, right? So specific rotation slowly changes to a constant value. To a constant value of 52.5 degrees, irrespective of whatever you have taken. We call this as mutarotation. Converting one form to another form. Or we also call it as anomerization. Why we call it as anomerization, sir? Both alpha form and beta form have difference in configuration only at first carbon. Remaining all carbons, relative position of atoms remains the same. Right? We can call them as C1 epimers. C1 epimers are also called as anomers. Right? So alpha D glucopyranose, alpha D glucopyranose, and beta D glucopyranose. Both are anomers. Or we call them as C1 epimers. C1 epimers are called as anomers. Any questions in this? Respond. You have any questions, sir?
No, sir.
No, sir.
This is how the structure of glucose was confirmed. So we have seen preparation and the structure of glucose. Same way, all these reactions are repeated to identify structure of fructose also. So I am writing that fructose. I am not going to explain that in detail. Just in short form, I will write all the preparation and means identification reactions of fructose. In short form, I will complete it, right? So I am writing regarding fructose. I will not explain them further because all the properties are same, right? Like glucose, fructose is also allowed to react with acetic anhydride, with acetic anhydride in terms of ZnCl2. What we got in case of glucose? What we got in case of glucose? Response, sir. With acetic anhydride, what we got? Pentaacetate confirms presence of 5 OH groups. See this one? Glucose with acetic anhydride forms pentaacetyl glucose. This reaction confirms presence of 5 OH group. That's why you got 5 acetyl groups. Same reaction I'm doing here. With acetic anhydride, I got pentaacetyl product. So pentaacetate of fructose. So this reaction confirms presence of 5 OH groups in fructose also. No, second reaction. Hydrogen iodide red phosphorus. HI red phosphorus. Now what we got in case of glucose with HI and red phosphorus? Response, sir. With HI red phosphorus, what we got in case of glucose?
Hexane.
Hexane confirms linear chain, right? Because HA and red phosphorus converts every functional group into alkane. So here also you got N hexane. So this reaction also confirms. Therefore, 6-membered straight carbon chain is confirmed. Now, another reaction. with HCN. What you got? Cyanohydrin. Here also you will get cyanohydrin. Means confirms presence of carbonyl group. This on hydrolysis. There on hydrolysis you got one acid. Here also you will get one acid. Right? This on reduction with HA and red phosphorus. I've got isoheptane. 1, 2, 3, 4, 5, 6. This I got isoheptane. Right? Means what it is confirming. And if it is aldehyde group or keto group, on adding HCN, what happens? Cn minus will attack here, this converts into OH. So I got OH here, I got Cn here. Then it will convert into carboxylic acid. This on reduction with HA and red phosphorus. These both groups converts into alkanes. Right? This what should happen. So if it is aldehyde, it becomes a straight chain. But you got branched chain. Means it is not aldehyde. So you have carbonyl group, but not aldehyde group. Means it must be a keto group. That too, it should be present at second position. So based upon this, we'll confirm presence of keto group at second position. Another reaction with hydroxylamine with NH2OH. Glucose gives oxime. Here also I got oxime. Glucose reacts with 3 moles of phenyl hydrogen. With 3 moles of phenyl hydrogen. Glucose gives osazone. Here also I got yellow color precipitate of osazone. Right? Both reactions confirm. Both these reactions confirm presence of carbonyl group. Here also I got oxime, osazone. So both these reactions confirm presence of carbonyl group. Same things we have seen in case of glucose also, sir. Any questions?
No, sir.
Sir,
Yes, sir.
can you explain that HCN reaction alone, sir?
Okay. I am taking this is glucose. I am allowing it to react with HCN, H plus Cn minus. Cn minus attack here, making this bond to shift, and H plus now goes to oxygen. So what you get? You get CHOH 4 times, and this converted into, here I got cyanide group, and this converted into OH group. Now I am doing hydrolysis. On hydrolysis, cyanide converts into carboxylic acid. So remaining carbon chain as it is. No, this now I am allowing to react with hydrogenated red phosphorus. So what it will do? Any functional group will convert into alkane. So this converts into alkane. All this chain converts into alkane. So totally here 1 carbon, here 4 carbons, here 5, 6. Totally, sorry, 4, 5, 6, 7. So you will get N-heptane. If you get N-heptane, it confirms all these carbons are in continuous chain. Instead of that, if I get isoheptane, what it confirms? This carbonyl group, this aldehyde group is not at the end. For example, if it is present like this, CH2OH, C double bond O, CHOH, 2, 3 thrice. Now, if it is allowed to react with HCN, now what you will get? The CH2OH as it is. Here you got OH group and cyanide, and remaining chain as it is. Now I am doing hydrolysis. Then cyanide group converts into carboxylic acid. Now I am adding hydrogenated red phosphorus. Then all carbon chain will convert into alkane. So now observe, this is one continuous carbon chain having one branch. So what you got? CH3. This is CH2. This converts into CH3. Here CH2 thrice CH3. So what I got? Isoheptane. Means it confirms carbonyl group is present at second position. Clear?
Sir, but when glucose is reacted with HCN, we'll get gluconitrile and malonitrile, no, sir.
Hey, both are, what are they? Both are epimers, na? Cyanide may present either above the plane or below the plane, because this is sp2 carbon. If it is sp2 carbon, cyanide can go and attack either above the plane or you may get below the plane. That's why you got this plus its C2 epimer. That's what we have already seen. Correct or not? Response, sir.
Yes, sir.
Over. Right? Whatever it may be, any type of epimer having cyanide group, which on hydrolysis gives carboxylic acid only, which on reduction gives continuous chain only. Over.
Yes, sir.
Right, sir. Now, with the NiH2OH, it gives oxime. With the 3 moles of phenyl hydrogen, you got osazone. Both will confirm presence of carbonyl group. Now, glucose with bromine water. Now, what you got in case of bromine water? Glucose with bromine water. What you got? Glucose with bromine water, sir. Mild oxidizing agent. Gluconic acid. With nitric acid, you got saccharic acid. Correct? Say something.
Yes,
So with bromine water, you got gluconic acid means confirms presence of aldehyde group. Here, no reaction. Means aldehyde group is absent. Therefore, aldehyde group is not present. No. With nitric acid, glucose with nitric acid gives saccharic acid. Aldehyde group converted into COH group. At the bottom, primary alcohol also converted into COH group. But here, with concentrated nitric acid, in fructose, carbon-carbon bonds also will break, forming oxalic acid and tartaric acid. What this confirms? Bond between second carbon and third carbon was broken. Then what happens? See this. This is the structure of fructose. If I break this bond and if I convert this into carboxylic acid, this also carboxylic acid. This converts into carboxylic acid, this also converts into carboxylic acid. So we got oxalic acid and tartaric acid. So formation of these two confirms C2, C3. This is 1, 2, 3, 4, 5, 6. So C2C3 bond cleavage confirmed. Right? Means carbonyl group is confirmed at C2 position. Now, instead of that, cleavage may happen here also because this is carbonyl system. Either this bond should break or this bond should break when I'm allowing it to react with strong oxidizing agents. If this breaks, I got these two products. If this breaks, this converts into formic acid, and this is the next carbon chain, right? So in addition to this, I may get formic acid plus COOH, OH, H, H, OH, OH, COOH. So this confirms cleavage at C1, C2. Right? So what is this product? 1, 2, 3. Trihydroxylutaric acid. As we are getting these types of products, anyhow, either this or both are obtained means, again it confirms presence of carbonyl group at second position, C2 carbon, right? If we have one carboxylic acid and one CH2OH, we call it as glycolic acid. Glycolic acid. Or they will give advertisement now. Glycolic acid for beauty, they will give this, right? To remove that tanning, to remove that black skin or layer over the surface of it, right? Any questions on this? Respond.
No, sir.
In the same way, like glucose, we also have seen some reactions to confirm the structure of fructose. Like glucose, fructose also exists in cyclic form. Like glucose, here also some rotation is observed, right? There we call it as mutarotation, but here I don't call it as mutarotation. So there, if I store glucose in water, slowly that rotation changes to plus 52.5 degrees. Correct or not? Alpha form 111 degree, whereas beta form 19.2 degree. As they are interconvertible, some amount of beta form and some percentage of alpha form both put together gives a net optical rotation of 52.5 degree. Same way, if fructose on withstanding naturally occurring fructose on withstanding, it slowly converts into minus 21. There it is plus 52.5. That's why it is called dextrose. Here minus 21. That's why it is called levolose, because it is levorotatory. Right? That's why it is called as levolose. Here also, for example, if you take the chain form, right? So I'm drawing the chain form CH2OH, C double bond O, 1, 2, 3, 4, 5, 6. So configurations yet third, fourth, fifth remains the same for glucose and fructose. Right? So configuration yet third carbon, fourth carbon, fifth carbon remains the same for glucose and fructose. Right? So this I call it as this is also having OH group towards right side. So this is also D. But if we withstand, it slowly converts its optical rotation to minus 92. Right? So I call this as a D minus fructose. D minus fructose. This on withstanding. Now here, this oxygen will donate lone pair of electrons to this carbon. So over this carbon, OH may be either above the plane or below the plane. But ring size now becomes 1, 2, 3, 4, 5, 5-member ring. So you call it as furanose. So the obtained form will be 5-member ring. Remaining all as it is. Remaining all substituents will not change except configuration yet second carbon. Except the configuration at second carbon, remaining doesn't change. So this is that second carbon. First carbon I am writing CH2OH as it is. Now OH. Here I may write that CH2OH below, because when this is attacking, this OH group may come either above the plane or below the plane. Here I wrote it below the plane. So now I am writing above the plane. Right? Now this is the sixth carbon. Here I am writing the sixth carbon, CH2OH. Here I am writing that sixth carbon, CH2OH. Now sixth carbons and OH group, second carbon OH group, both same side, both opposite side. Opposite side means alpha form, same side means beta form. When we are writing the remaining groups which are towards the right side, I have to write them down. So at third carbon, H should be written down. So OH, H, sorry, this becomes OH. This becomes H. Now fifth carbon, CH2OH I have written. On fifth carbon, oxygen I have written, so this is hydrogen. So hydrogen, H, OH, OH, H. So I call this as alpha D minus fructofuranose. This is called beta D minus fructofuranose. Right? It is having an optical rotation alpha D and T degrees centigrade. This is approximately equal to minus 21 degrees. This is approximately equal to minus 133 degree. So net rotation will be negative only because both forms are negative. So therefore, at equilibrium, net value is approximately equal to minus 92 degree. If it is minus 92 degree, tell me what is the percentage of alpha form and what is the percentage of beta form? If it is minus 92, what is the percentage of alpha and what is the percentage of beta? Let me assume this as x. X into 21. Then this will be 100 minus x into 133. Net value must be equal to 92. So 21x plus 1300 minus 133x is equal to 92. So bring this to this side. So 133 minus 21 means 111. 133 minus 21, 112. So 112x is equal to. This also goes to that side, becomes negative. So 1392 divided by 112. So it is 12.4. Means this is approximately 12.4%. This is approximately 87.6%. Any questions, sir?
Sir, you have
Respond.
No,
added
sir.
1392, sir.
Yes, sir.
You have added the 1392, sir. You have to subtract.
Oh, subtract. Huh? Oh, let me check. Let me check again. Let me assume this as x into 21 plus this is 100 minus x into 133 equal to 92. Correct? Huh? So 21x plus 13300 minus 133x equal to 92. Correct? Huh? Now this is minus 112x. If it brings to this side, I need to subtract. Correct? So 13300 minus 92. That is 13208. So x equal to 13208 divided by 112. Hey, I am getting higher value, man. I'm getting higher value. Minus, this is also minus, then it is plus, this is negative. Negative goes to that side positive. So it will be positive. So it will be positive only. So 13208 divided by 112. Alright, am I doing anything wrong? Same thing only, no? Let me write as minus 21x. Then this will be remaining percentage, means 100 minus x into minus 133. Net value must be equal to minus 92. So wait, percentage, na? So divided by 100 means 9200. So this becomes minus 21x. This becomes minus 13300. This becomes plus 133x is equal to minus 9200. Then this becomes 112x. This is equal to 13300 minus 9200. So this becomes 4100. So x equal to 4100 divided by 112. So I got this as a 36.6 percentage, and this becomes 63.4 percentage. Now is it clear? Response, sir.
Yes, sir.
So this is about structure of glucose and structure of fructose, right? Now coming to disaccharides, we have majorly 3 disaccharides in our syllabus, right? Only 3 disaccharides in our syllabus. One is sucrose, maltose, lactose, right? Now I am talking about sucrose. Now, glucopyranose and fructopyranose. Already you know the structure of glucopyranose. No, you know the structure of fructopyranose. Glucopyranose you know, fructopyranose you know. Now both bring together and remove one water molecule, right? So now see the structure of it. This is glucopyranose ring. Now I am writing a 5-member ring. So this is fructofuranose. Now I am taking alpha D-glucopyranose. I am taking alpha D-glucopyranose. Alpha form means what? How it should be? Alpha form means how it should be? CH2OH and OH must be opposite, correct or not? Alpha form means CH2OH, OH must be in opposite direction. So CH2OH, OH. And I am taking beta D fructofuranose. Beta D fructofuranose. This is beta D fructofuranose. I am taking this form. This is beta fructofuranose. This is alpha glucopyranose. Now, observe this group. Is it hemiacetal group or not? Response, sir. Is this hemiacetal group or not?
Yes, sir.
In the same way, observe here also whether this is hemiacetal group or not. Right? Carbon.
Yes, sir.
On that one, carbon is there. This side O is there. OH is there. Carbon is there. So both have hemiacetal groups. Sugar with hemiacetal group is called reducing sugar. Right? So because of presence of hemiacetal group, it is also a reducing sugar. Because of presence of hemiacetal group. Same way hemiacetal group is present in glucose also. That's why it is also reducing sugar. Here also hemiacetal group is present, therefore it is also reducing sugar. Now I am connecting this OH group and this OH group, and I am eliminating water. Right? So how can I do it? How can I do it? And I need to remove water from these two. So how can I do it? Observe. Is it beta form or not? CH2OH, OH group, both are on same side. Is it beta form or not? Respond. I brought that OH towards right side. Just on that molecule I have flipped. Clear?
Yes, sir.
Yes, sir.
Now, again I am flipping vertically. Is it beta form or not? Now, is it possible to remove water from these two? Right? Is it clear? Respond. Any questions? This CH2OH, this OH, same side, so beta form. Here opposite side, so alpha form. Right? So I am writing remaining things as it is. So I am writing CH2OH here, OH here, this side H, CH2OH, right? I need to write that O that side, right? Means if I am writing O above, I need to interchange these two. So I am writing OH here, HOH here. Any questions, sir? Do you have any questions in it? And just I am rotating the molecule, man, nothing there. Or I am taking mirror image 2 times. Clear? Any questions?
No, sir.
Now,
No, sir.
for glucopyranose also I am drawing it. So H, OH, OH, H, here H, here OH, again H here, OH here. Now from these two I am removing water. I am removing water. If I remove water, I got this one. Right? I will delete this. Now, is this second carbon or not? In case of fructose, this is first carbon, second, third, fourth, fifth, sixth. In glucose, this is first carbon, second, third, fourth, fifth, sixth. So this is the linkage between first carbon of glucose and the second carbon of fructose. That's why it is called C1C2 glycoside linkage. Any questions? The two, as both are on same side, I call it as alpha glycosidic linkage. If one below, one above, then I call it as beta glycosidic linkage. So I call this as alpha glycosidic linkage. Any questions?
Okay.
So C1, C2, alpha glycosidic linkage. Now, if I do hydrolysis here, I am doing hydrolysis, then what I will get? This will break, glycosidic linkage will break, right? Then I will get alpha D glucose plus beta D fructose. This is minus 92.4 degree. This is plus 52.5 degree. As one more of this, one more of that is obtained. Now per mole, what is optical rotation means? Overall optical rotation per mole will be subtract means approximately minus 40. Minus 40 by 2 means approximately minus 20 point something. Correct? Response, sir.
Yes, sir.
Initially, this sucrose has an optical rotation of, this is approximately 66.5. After hydrolysis, net optical rotation converted to negative. This change in optical rotation is called inversion, right? This change in optical rotation is called as inversion of Kinshubin. Now tell me, in sucrose, do hemiacetal group is present or not? Do hemiacetal group is present in sucrose or not? Response, sir. In fructose, this is the hemiacetal group. In sucrose, hemiacetal group and fructose hemiacetal group got connected. Means that OH group is not free. Correct? If that OH group is not free, is it reducing sugar or non-reducing sugar? Response, sir.
Non-reducing.
So there is no free hemiacetal group, right? That's why sucrose is non-reducing sugar. Any questions in it? Right? Non-reducing sugar means no positive test for. There is no positive test with failing solution. Benedict solution also fails. Tollens test fail. Right? 2,4 DNP test fails and so on. All these tests are not positive. Right? No. This hydrolysis can be done by using enzymes also. So on fermentation, by yeast, right? C12, H22, O11 undergo hydrolysis in presence of an enzyme. This yeast produces an enzyme called invertase. You will get glucose plus fructose. If I use another enzyme, zymase, glucose and fructose both will convert into ethyl alcohol. This is what we do in distillery industries. Any questions about sucrose, sir?
No, sir.
Next, regarding maltose. Maltose. Now, starch. Starch is a polymer. So I am writing C6, H10, O5, N times. This on hydrolysis. Right? Using an enzyme diastase, you will get maltose. Maltose is C12, H22, O11. Same. Sucrose is a disaccharide. Maltose is also a disaccharide. So if I take 2 moles of it, then I will get N moles of it. You will get maltose. This maltose, in presence of another enzyme, maltase, it converts into glucose. Right? So it is having only glucose, means I am taking 2 glucopyranose rings and I am connecting. Right? 2 glucopyranose rings I am connecting. So I am taking this ring. So I am taking glucopyranose ring. Right? This is nothing but alpha D glucopyranose ring. Second molecule also I am taking. Now, this is also alpha D glucopyranose. Right? Both are alpha D glucopyranose if I write OH group here. Now, in this case, I am changing these two. Now what is this one? This becomes beta D glucopyranose now. Response, sir. Correct or not?
Yes, sir.
Now I am eliminating water from these two. Now this is the linkage between C1 and C4, correct? Or? See, this linkage is between C1 and C4, right? Earlier linkage is between C1 and C2. Here it is between C1 and C4. Now what about this C1? This is free now. Therefore it is reducing sugar, correct, sir? Or a C1 carbon, this hemiacetal group is free only now. So it is reducing sugar due to presence of hemiacetal group. Any questions in it?
No, sir.
Now, because of presence of this hemiacetal, it can react with all these reagents. React with the Tollens reagent, failing solution, react with hydroxylamine, etc. Right? It can form wasazone also, because glucose and fructose both shown positive test for wasazone due to presence of this free group, right? So it will form wasazone also. Right? And this linkage is it alpha linkage or beta linkage? This linkage. Both are on same side. Correct or not? So I'm writing C1, C4 alpha glycosidic linkage. Any questions, sir?
So can this linkage happen between two alpha D glucose, sir?
Yes, you can do. Right? You can do between two alpha. If I am taking alpha and beta, hey, oh, sorry. We are preparing maltose, na? In case of maltose, it should be between two alpha forms. Right. Now it is called alpha. Done, na?
Yes, sir.
If I take one alpha, one beta, then it is not called as maltose. Right? Right. Now coming to next one, sir. Lactose.
Sir, can you please scroll up, sir?
Milk sugar. Yes, sir.
Thank
So
you,
I am
sir.
copying that same. I am copying the same. Now what is this one? If you have OH group below, then I call it as alpha D glucopyranose. Instead of this, if I take the OH group here, then it is beta D glucopyranose. Now I am taking another one. Now, if I take this CH2OH and here also OH above. Now this is also beta form only, because the CH2OH, the CH2OH, both are on same side, right? So beta form only. Now observe, I am removing water. Have you found any difference, sir? Have you found any difference between these glycosidic linkages? Both OH groups are same side here. Here both OH groups are on opposite side. Then we call it as beta glycosidic linkage. Here I call it as alpha glycosidic linkage. Here I call it as beta glycosidic linkage. And linkage is between first carbon and second carbon. Now, in addition to that, one small change we are doing. Right? What is it? One more small change I am doing, sir. If I change relative position of OH group at any one carbon, then it is called epimer. Right? Now observe here. I am changing configuration at fourth carbon. At the fourth carbon, I am changing configuration. Then this become C4 epimer. What is C4 epimer of glucose? What is C4 epimer of glucose? Observe, sir. What is C4 epimer of glucose? Galactose. So as I am changing configuration at fourth carbon, I call it as now galactopyranose. Any questions? This is glucopyranose only. If galactopyranose beta form and glucopyranose beta forms, if I connect them from C1, C4, then it is called lactose, right? C1 of galactose should link with C4 of glucose. Now tell me, is it reducing sugar or not? Response, sir. Is it reducing sugar or not? No one is responding. My time is getting wasted. Means. What about this C1 carbon? Hemiacetal group is 3. Means this shows positive test for failing tolerance and so on. So this on hydrolysis gives D-galactose and D-glucose. Galactose and glucose are C4 epimers. There is linkage between first carbon and fourth carbon. So it is called C1, C4 beta glycosidic linkage. Because of this hemiacetal group shows positive test with failing tolens, hydroxylamine, vasozone, etc. Right? Now, beta forms, in order to break beta forms, emulsin is required. So, hydrolysis of beta glycosidic linkages are done by emulsin, which enzyme specifically hydrolyze beta glycosidic linkages. Alpha glycosidic linkages can be hydrolyzed by using any reagent, any acidic medium or water also hydrolyze, right? But beta glycosidic linkages will be hydrolyzed with specific enzymes. which is an enzyme that specifically hydrolyze beta glycosidic linkages. So this is about sucrose, maltose, lactose. Next one. If both are beta D-glucopyranoses, if both are alpha D-glucopyranose, we call it as maltose. If both are beta D-glucopyranoses, then it is called cellobiose. Next one. Cellobiose. So what is this one? What is this one, sir? If I write OH here, what we call this as? CH2OH, OH, opposite side, alpha form. If I write that OH here, beta form, right? I am taking another mole of the same. Another mole of the same one. Now both are beta, and I am removing water. Now tell me what type of linkage it is. Alpha linkage or beta linkage? This glycosidic linkage.
Beta glycosidic.
Beta form, right? Now, if I do hydrolysis for it, on hydrolysis, I will get both 2 moles of, you will get beta D glucopyranose. Right? Now, do it have hemiacetal group? Do cellobiose have hemiacetal group or not?
Yes, sir.
So it is reducing sugar. This first carbon is free. Linkage is between C1 and C4. So I am writing C1, C4 beta glycosidic linkage. Right? As C1 is free, it will shows muta rotation, reducing sugar. As it is reducing sugar, it react with Tollens, Failing, Benedict. It forms Wasozone. All these tests are as usual. Right? As this linkage is also beta, it also will be hydrolyzed by emulsin. Now, this is about disaccharides. We have 2 polysaccharides in our syllabus. One is starch, another is cellulose. Right? If you complete these 2, carbohydrates part is over. Now, first let me start with the starch. Polysaccharides. Examples of polysaccharides: starch, cellulose, animal starch, glycogen, dextrins, etc. These are all examples of polysaccharides in which we are studying about starch. We write it as C6H10O5 N times polymer. Starch is present in all plant seeds. Starch is present in all plants, especially in seeds. Example: corn, maize, wheat, potatoes, rice, barley, sorghum, etc. Right? Next. It is white amorphous substance. Less soluble in water, almost insoluble in water. On heating, slowly solubility enhances. It is used as an indicator for iodine by imparting blue coloration with iodine, where iodine molecules are trapped inside the moiety of starch, right? Blue coloration is observed with iodine. Now, if I heat, color will disappear, and on cooling, color will reappear. So color disappears on heating and reappears on cooling. Now, on hydrolysis, C6H10O5 N times. On hydrolysis in presence of dilute acids gives C6H10O5 N prime, means long chain will break down to smaller chains where N is greater than N prime. On further hydrolysis gives maltose. This on further hydrolysis gives glucose. This with enzyme diastase gives maltose. Now, observe the structure of it. All are alpha linkages. All C1 carbons are linked with C4 carbons of next chain. So I am taking glucopentanes. Oh, sorry, this is beta form. Now this is alpha form. This is alpha form. I am writing one more alpha form. one more alpha form, and it goes on. Now I am removing water here. Glycosidic linkage. Here also same. Glycosidic linkage. So all are alpha glycosidic linkages. Here also I will remove this and I will write some chain. It goes on. Here also I will remove this and I will write some chain goes on. Right? Any questions, sir? Respond.
No, sir.
No, sir.
In this way, if you have only linear linkages, then it is called amylase. If this chain links with another chain at C1 and C6 carbon, then it is called amylopectin. So starch is combination of amylase and amylopectin. So starch is a mixture of amylase and amylopectin. Approximately 10 to 20% of amylose is present and 90 to 80% of amylopectin is present. Now, as there is no free hemiacetal group, starch do not give wasazone. And it is not reducing. Therefore, starch will not show positive test with tolerance, failing, Benedict, and so on. Right? So this is amylase. In amylase, you will have C1, C4, alpha glycosidic linkages. Approximately 100 to 300 glucose units are present. Molecular weight approximately 10,000 to 50,000 units. And it is a straight chain polymer. We also call it as linear polymer. As it is a linear polymer, to some extent, it is soluble in water. And it shows blue color with iodine. This is about amylose. I am taking two such units of amylose. This is one amylose unit. This is second amylose unit. Now, two amylose units I am connecting through first carbon and sixth carbon. From this sixth carbon and first carbon, I am removing water. So now I got one more link. between first carbon and sixth carbon. Is it clear, sir?
Yes, sir.
Yes, sir.
Then we call it as amylopectin. Amylopectin, right? So here you will have C1, C4 linkages and also C1, C6 linkages. So I'm writing the same. You will have C1, C4 alpha glycosidic linkages, right? Approximately 25 to 30 such units are present. After every 25 to 30 units, these chains are further linked with each other via C1 C6 linkage, right? Now, because of this polymeric form, complex form, this is water insoluble. That's why if I heat, the C1 C6 linkages will break and it becomes amylose and it becomes water soluble, right? Otherwise, it is water insoluble and it does not show color with iodine. Right? Now, to hydrolyze starch, we will follow an enzyme, we will use an enzyme called amylase, which is found in saliva. So, starch is hydrolyzed by amylase, which is found in saliva. Any questions, sir?
No, sir.
So we are done with one polysaccharide, that is starch. Next one, cellulose. Next one, cellulose. Starch have all alpha forms. Cellulose have all beta D-glucopyranose linkages, right? Starch have alpha linkages. Cellulose, formula I will write as same, C6, H10, O5, N times. So it is the major ingredient in most of the cell walls. In plants. Example, wood, cotton, etc. Wood approximately 45 to 50% is cellulose. Cotton is approximately 90 to 95% is cellulose. Right? So major ingredient in cell walls. Now if you see its structure, all these are alpha linkages, right? Now I am changing it. I am writing OH here and H here, right? Now I am connecting this to this. So it is beta glycosidic linkage. Same way here also. I'm writing H here, OH here. And it goes on. Any questions are in this? Response, sir.
No, sir.
Right? So it have all beta D glucopyranose links. Linkage is between C1 and C4. So we write as C1, C4 beta glycosidic linkages. If I do hydrolysis, what you get, sir, on hydrolysis? All will be beta glucoses. Correct? On hydrolysis means heated with sulfuric acid under pressure. Any questions, sir? Now tell me, is it reducing sugar or not reducing sugar? Starch as well as cellulose. Is it reducing or non-reducing?
Non-reducing, sir.
So it is also non-reducing sugar because that hemiacetal group got linked further and further. So non-reducing sugar. So fails to give all the tests like fairing, Torrance, Benedict with NH2OH, all these tests fail, right? So does not react with failing, Torrance, etc.
Sir,
Do not give Vosozone. Right? No. Cellulose.
Sir.
No, yes, sir.
sir, can you explain why it does not form ozazone?
Hey, this hemiacetal group is not free. How Vosozone is formed? Because of that free group, phenyl hydrogen will react. Correct or not?
Yes, sir.
See this? Because of this groups only, phenyl hydrogen will react and ozone will be formed. Right? If that hemiacetal group is not there, they cannot form ozone. So all which is having all reducing sugars, which are having that C1 carbons OH group free, they will show positive test for ozone. Any questions are in it?
No, sir.
No, sir.
Cellulose, like starch, it cannot be hydrolyzed, not be fermented, right? Starch on fermentation with yeast, you will get glucose, right? Which on further fermentation to form alcohol, right? So cellulose, because all are beta glycosidic linkages. So I require special enzymes, right? Emulsin. So it is not fermented by yeast. And is not hydrolyzed like starch. It is used in manufacturing of rayon. polymers, right? Gun cotton, etc. One note. In ruminant mammals like cattle, sheep, right? They have an enzyme called cellulase, right? Or cellulolytic bacteria, which will break down these cellulose into glucose units, right? That's why they can digest large number of cellulolytic bacteria in stomach of ruminant mammals like sheep, other cattle, will break down beta glycosidic linkages by using an enzyme cellulose enzyme. So this is about starch and cellulose, right? Whereas animal starch, what is it? Glycogen. Correct? It is having structure similar to amylopectin, but more branched. Let me write that also. Glycogen, we also call it as animal starch. Right? Carbohydrates are stored in animals in the form of glycogen. Correct, sir? Right? Its structure is similar to amylopectin, but more branched. Major it is present in liver, muscles also. Huh? Muscles are not present in liver, present in muscles. Yes or no? Bio students. No. If you don't eat food.
Sir,
Yes, sir.
how in brain, sir?
It is purely made up of carbohydrate only and protein part. Yes or no?
Yes, sir.
Then
Okay, sir.
and when you don't eat sufficient food, most of our sugars will be stored, our carbohydrates are stored in. Bio students, you need to say where that most of the sugars will be stored in our body. Intestinal. When body needs glucose, enzymes break down glycogen into glucose. This is found in certain type of bacteria also, fungi also. So also found in fungi, certain type of fungi, and also certain type of yeast. Right, sir? Any questions, sir, in this?
No, sir.
So we are done with carbohydrates part. Biomolecules chapter possess carbohydrates, proteins, vitamins, and nucleic acids, right? In which carbohydrates part is over. So next we
Sir.
need to start proteins part, right? Better I will
What
stop
about
today's discussion.
gums and pectin, sir?
Yes, sir.
So
No
what
need
about?
of it,
Okay, sir.
right? Right, sir. This is about carbohydrates part. So in next class we will see proteins, of course, and amino acids also, right? Proteins are nothing but polymers of amino acids, right? Majorly found in meat, fish, milk, right? And maybe cheese, some pulses also, in which alpha forms of amino acids are really necessary for us, right? These amino acids are classified based upon their pH also into acidic, basic, and neutral, or based upon requirement, whether our body is able to synthesize it or not. If it is necessary for us to take through diet, we call them as essential amino acids. If it is synthesized by body, non-essential amino acids, correct? Any of you, what are essential amino acids? What are essential amino acids, sir? Isoleucine, leucine, valine, methionine, phenylalanine, tryptophan, threonine, histidine, arginine. Correct? Huh? I love Lucy very much. Please try to help me, arginine. Yes or no?
Yes, sir.
Sure.
Right, sir. I will stop the discussion, today's discussion. We'll continue later.
So do we have class tomorrow?
Yeah, tomorrow there is no one to take class. All are on leave. I have to take. Tomorrow, day after tomorrow also, I think all are on leave. This week alone, I told now, this week alone, you will have most chemistry classes only. Tomorrow, day after tomorrow, you have chemistry class.
So Saturday for
Tomorrow
weekend.
anytime can write an exam, sir.
Yes, yes.
Tomorrow we have exam, sir. Can we attend it anytime, sir, in online?
Exam, oh, this one. You can attend that exam anytime, man. Not only tomorrow, it will be open till I think 1 month or 2 months, it will be open only. So take sufficient time, prepare for the exam properly, and then give it. If you feel that your practice is not sufficient, you let me know. I will solve another 1 or 2 papers for chemistry. Okay, wow.
It's not a specific data, sir.
It is open from tomorrow. Right? Tomorrow it will open and it will remain open only. But you need to complete it within a month because they need to do the analysis also, no? Based upon your way of approaching the paper, they will give you that analysis, right?
Yes, sir. Okay, sir. Thank you, sir.
So for that you have to give, right?
Sir, what test, sir?
Hey, these 8 years plus students, they have test tomorrow. It is not for everyone, only for those 8 years plus enrolled students. Right? Any other questions? If you have, you can ask. Or yes, Harshada.
Saturday also we are having classes, sir.
Saturday, your weekend batch, na? Saturday class as usual, na? Weekend students.
Chemistry, sir. Chemistry, sir.
Saturday chemistry, yes. Sunday, I think Sunday they are not giving class. Sunday you have ATS exam, I think so.
Yes, sir.
That's why chemistry class is on Saturday. Okay, I will do one thing. For that exam, I will solve one paper, one advanced paper. Last year's ATS advanced paper I will solve.
Okay, sir.
Tomorrow one class I will solve one paper. Friday I will try to solve one more paper. It will help
Okay.
others also.
Okay, sir.
Right, sir. Okay, shall I close the session?
Yes, sir.
Sir,
Thank you, sir.
Yes, sir. Yes, sir.
thank you. Sir.
Thank you, sir.
Yes, sir.
Thank
Bye,
you,
sir.
sir.
Sir,
Yes, sir.
posted.
Thank you, sir.
Yes, Aparajita.
Sir, which book, like which module number has biomolecules?
I think module 6, I think so. 5 or 6.
When will we get that? Like now only 3 we
It
have
is already
received.
available in your Mayakash app. It is already available.
Okay, sir.
Mostly September 2nd week, we will get the target booklets. We haven't received the targets. Mostly next week, you will get it. Okay, sir.
Sir,
You are free to leave.
C6H,
Yes, sir.
molecular formula C6H10O5, the whole N வந்து polysaccharide, all polysaccharide
All
is
polysaccharides will have same formula, no? Because they are all linked by losing one water molecule, right?
Yes, sir.
So that's why they will have same formula, whichever having that polysaccharide systems.
Sir, how to name nomenclature? How to which class you use?
Yes, yes.
Nomenclature how to find, sir? I don't know.
Nomenclature of what?
These molecules, glyco. No.
6-membered rings means pyranose, 5-membered means furanose. It is obtained from glucose. That's why glucopyranose. If it is obtained from galactose, galactopyranose.
Okay, sir. Sir, you teach us,
Sir,
sir,
no.
this.
What?
This naming you teach us, sir, first starting of the lesson.
See, I think yesterday only we discussed. All are obtained from glyceraldehyde, which is a triose, then tetrose, then pentoses, then hexoses. In hexoses, 8 types are there. The 2 D forms, in which we are studying only 3. Glucose, mannose, galactose. That's all. Only 3.
Okay, sir.
Yesterday only we discussed.
Yes, sir.
Right, sir.
Sir, when will you post these notes, sir?
Now itself I am posting, man. Now only I am posting. Yes.
Can you solve one paper based on coordination compounds?
Coordination compounds, huh?
Oh, yes, sir.
Yes. Maybe shall we solve tomorrow? Tomorrow one paper we will solve based upon coordination compounds.
Sir, along with that
Maybe
advance.
You have now for mains you have this coordination compounds also.
No, sir. Coming September 6th, I think, coordination compounds exam, sir.
And then whenever you say, then you let me know. Then I will solve one paper.
Okay, sir.
Anything else?
Sir, notes and Irene's.
Yes, yes.
Alkanes and Irene's notes.
Haloalkanes and arenes notes I will post on this Saturday. Mostly this Saturday I will complete that and I will post it. Anything else?
For AAPS plus exam, can we give any time?
You can give anytime, ma'am. You can give it
Okay,
anytime.
sir.
It will be open, right? You take sufficient time.
Okay.
That's why I'm saying you prepare properly, right? Based upon your preparation, AI will give that analysis. So you prepare